Haha. Not late today? What's going on? Hello Dodge Taurus, hello Max, hello Fruchti. Yeah, I'm freshly showered just for you. Lab still not cleaned up, a mess, but I installed a few lights. I've installed a few lights, maybe I show that. It's TTS working right away. Okay, don't get sick. I moved the camera to show you. Okay, I have some, these are from Norma. So anyone who's living in Germany knows like this is a supermarket, and I got few of those and just installed everywhere. So I have a little bit more light here, which is beneficial for some way, maybe even for my mood. Okay, we have the Spreewald saure Gurken, only sour is good pickles. No buffing, you lie. Okay, and also the fondue, fondue to angles. Oh, I found the lid that's fitting, but I need to spot weld this back on, or maybe. Okay, let's heat that up. I hope my lab won't stink again for a week like last time. And here we go. So what's the plan for today? Let's not waste any time. Last time we stopped at a high. Hello, Alexander. At the point where we were not able to program the FPGA anymore. And then I even restarted my computer, which doesn't happen very often, because I thought it might be some way I might have like shorted the USB or whatever. So, but it wasn't that. I show you a thing. Maybe that helps if you, some of you bought already. No, it's not broken. I thought I have to solder the pin headers to another one of these FPGAs, but it's not the case. Let me show. FPGA is back online here. Wait, do we have the cam again? Whoop. Yeah. Okay, FPGA, zoom in, bath. Here you go. Okay, so issue was it wasn't like device wasn't able to be found, and I remembered that I changed a setting. I hope I don't dox myself. Where's my screen capture? Here we go. Oh, that's the wrong screen. Okay. Let me. Oh, this is not a. This is. Which one is it? Is this one? Yeah, this is the screen capture. Okay, here's the screen capture, and I remember that we changed something in configuration, because we had some errors, and I thought, oh, maybe it's something with the pin, dual purpose pins. And what I changed is use JTAG as regular I/O. And as soon we program it with this thing, JTAG, why is my, oh wait, my camera turned off. Okay, wait a second. Yeah, almost like JTAG is basically like the interface, the communication interface. However, let me plug in back the face cam, because that turned off apparently. Yeah, a slight problem, because JTAG is used to program the device and upload to SRAM and so on. I hope my face is back on. And the way you can Yeah, so the way you can still program, I just guessed what we can do. Use the reset button, keep it pressed, and then push upload, and then everything works. So you still can, you are able to upload when holding down reset. So this is basically same as with ESPs, apparently. So this one is recovered. We were able to program it, but I want more. Oh, this is the camera. It's let's zoom in a little bit. No more mess. Who joined? Did I say hello to M40K? I don't know. Chris and Mikael. Hey. So yesterday was a cool hangout. I don't know, you peeps missed it. We were like 3 hours chatting and it was funny. Forcing flash mode, yes. Yeah, but except for ESPs, I'm not familiar with anything here, and this actually worked. So it's not easy breakable, it seems. I didn't break it yet, so these are fine. And for today, what I'm thinking is the best to not start like with everything at once. Let's just try to start with writing the output pin, so that would be the clock and the chip select, and basically scoping it. If that works, we will switch to reading the digital pins 1 to 8 and test that with basically a jumper wire here and LED for that. So we can basically take a few LEDs and whenever the pin is set, so something very rudimentally simple, so we don't have like wondering what's happening there. Very, very cool. Okay, this is like the structured work. We might use for that our building phase monitor here. When I see that, that was ambitious back then. Now we just want to see an LED be set. Okay. Ray tracer. Okay, now let's remove all that. Let's remove all that. Huh? What flavor of ADC are we using? This flavor, I don't know which one that is. This is probably the one mega sample one. I will check my listing Mauser. Okay, so program FG fix JTAG, just so we have JTAG. Okay, next step will be test output output chip select and CLK. Okay, test select, and then next will be test DIN 0 to 7. Hey Adam. Then next thing will be, let's move that. This is small. Can you even read this? Okay, here we go. I'm working here a multi-screen setup. ChatGPT to make your to-do list. Again? Okay. Let me, nah, let's not waste time. Let's not waste. We are with serious business today. We can ask it to do like yeah, maybe some Verilog for us. Okay. Did bitluni die? What happened? I can't hear. Yeah, you were kidding. Okay. No, bitluni is still there. Okay. Here we go. Okay, we're testing the pins. Then we want to test an actual sampling. Yeah, let's do it. Let it do system Verilog then. Okay, then actually read a sample, huh? Should we read a sample and then how do we display it? How do we display the samples? We can use a read sample and to LED. Okay, so we have like a small like values with the LEDs, like so we can see. Hey, Wooden. And then last step would be use show samples on LCD. Okay, we might need like, I don't know how much, we don't have many flip-flops. Yeah, that's what I think, but we need an IP block for that. So that would be interesting. Maybe, but I don't think that ChatGPT knows Go in IP block specs. We might need to read the specs. Okay, try BRAM. I think they have like built-in PS RAM block FIFO. Oh no, not BRAM. Dual link. No, dual link FIFO, something like that. Show samples on LCD, and I think this is all we stretch goal. Stretch goal, show samples in pink or whatever. Hello, scope output. Yeah. Yeah, basically that will be a scope, and that's already a nice little project that's worthy a video, most probably. Okay, so maybe HDMI, but I don't want to like stress it, rather HDMI. I have even like a mini HDMI screen, this one here, so this is like else. Wait, is this a similar? Wait, is this a similar interface? No, it has way more pins. Okay, this has way more pins. Probably it's no. No, not doing that. I forgot how that works. Okay, so yeah, this is our to-do list for today. Now an important thing to do right now is, oh, I don't have a spoon. How is that? This is not heating up at all. Okay. But I have a fork. Huh? Bypass the HDMI and MIPI. Oh, do you? I thought MIPI is like. Is there an open implementation? Oh, we can ask ChatGPT. But how does that work? What is the interface? Yeah, I think it was. Yeah, it's turned on, but not really very hot. And we need to give it some juice, some extra juice. Yeah. This is like the best. Self-stirring fondue. Yeah. Yeah, I have an old drill that we can use for that. Fix the fondue. Oh, that now it's heating up. Now it's heating up. I noticed the laugh is overdriven, but I don't know how to change that, unfortunately. I set down the, it didn't change with the setting on the receiver here. It feels like when I replay the audio, it's quite hot. Maybe I just put it somewhere else, but then it will be maybe a little bit noisy. Fusion heater, fusion reactor. Okay. Oops, I bumped the cam. We don't waste time today for the setup. Anything. I have everything with me, and the chat, the tech TTS is working. This is fine. Oh yeah, now it's cooking. Now we are talking. We're cooking it in bear schnapps. There we go. Hey Sniff, guess what? Bitluni is working right away. No complaints today. No where is it pointing? Here we go. Pop. Schnapps. Yeah, I don't encourage people consuming alcohol. Okay, yeah, let's continue. Oh, I need some boost here. Speed. This stream is not sponsored by Speedster. The power of energy, but sugar-free. How does it give me energy without any sugar? You're drinking alcohol. Ooh. Okay. So let's switch to this one here. No, where's my fondue? Wait, chat, fondue, cam. Oh. Desktop, fondue, chat. Wait, why is it 40? I think it is 40. It must be, yeah, it's 40. So screen capture on, up, and this goes small, like that, and we just, oh, the plant is big, and we start simple this time. Okay, let's go top. What did we want to upload here? I completely forgot. Okay, let's turn Let's measure scope on. Scope on. Bath cam. I should make it. Oh, it's not plugged in. Oh, setup waste time. Where is it? Where is the scopy scope plugged in? Hello, Mister. Who is this? Mr. or Mrs. Hey, Johnny, and hello, Johnny. Yeah, you missed everything. We were already talking about JTAG and the importance of project settings and the reset buttons and density of the schnapps. Here we go. This stream is not sponsored by Keysight. Taxman, yeah. Oh, Taxman, you always remind me that I have to finish my taxes until Friday, because otherwise I may get fined. Okay. We want to test. Okay, this is 910. This is the outputs here. Okay, so how do I test it? I need the probe. Okay, here we go. Here we go. Okay. Fourth. Nice. Oh, congratulations. Okay, here we go. I think ground was in the center, yeah. It must be. Yeah, there is the ground. Okay, now let's check the code. What is even happening here? What is that? What is this? What is happening there? 3. There is something happening. Let me auto scale. Yeah, but it will. No, that's. Here we go. Okay, fondue is ready. It doesn't look like it's like really super cooked, but I can turn it down a little bit. Okay, let me test. A good bread today. Needs a little bit cooking. Okay, that doesn't look like anything is happening here. So let's basically disable this. Oh yeah, that's also for me. Which means it works, huh? It works. Okay, let's program it. Let's flash it. Okay, it's programmed. We should, to not destroy the flash, we should change, I can show that, programming, we should change it to SRAM. So this won't be permanent here. So we can basically write to SRAM and not kill the flash at some point. I think how many we have, 1000 write cycles, or who knows, before it breaks. Oh yeah, that was fast, and it's faster. Okay, now this is the module. I should also clear the output. Where is our LCD clock picks? Where's our ADC 8? Okay. Sample clock ADC CS and ADC CLK. Hey Christian, have a good work. Okay, now shouldn't it, so we have ADC, output ADC clock, shouldn't it like switch now and then? Okay, let's try basically use CLK and see what happens. ADC CLK bit index, whatever that means. Okay, let's try that. Do we have any serious warnings except for stripping? Oh. What? Okay, input user button is unused, ADC in is unused, and clock signal cannot be used as data signal. Yeah, that's too fast then. Yeah. Okay, this should be right. This tilde is right, isn't it? Am I wrong? So why do we? Where is my trigger? Single. What is this? What is this? This is noise. I don't know what this is. Nine bits. Decimal. Yeah, that doesn't mean anything. It might be still too fast. Okay, let's slow it down. Oh shit. Yeah, now we need a little bit more bits. Oh wait, I didn't save it, most probably. Let's check it. Now we have something really slow. What is... unwritten bits, unwritten, has no driver. 1 1 1 1 1 1 1 1. Okay, however, that should still work. Let's write it and be done. What? Photo? What is? The whole, it's inverting each bit, but this is like a 1-bit signal. We can also do like that, but that doesn't change much, I think. Wait, why is... What was the problem with... Oh yeah, that's LCD. It's complaining about LCD not being driven anymore. Yeah. Let's check if it... Is it even uploading? Huh. Okay, let me check if... Oh, SRAM program. Here we go. I bypassed it. Oh, I'm stupid. Sorry. Okay, but this is still faster. Okay, now we see nothing. Okay, let me try. So don't change too much. Full adder properly with the 1-bit addition. Yes, it does. You can even save like gates if you add a smaller number, because you have then just handle the 1 overflow bit. If it's assembling, like synthesizing it from... Okay, you know what? Let's just do 0 here and see what happens if we have even slight control over... Oh wait, it might not be CS that I'm reading here. What am I reading? I don't know what I'm reading here. Maybe we should CLK as CS. I don't know which one of the signals is even... Let's do 1 bit binary. Yeah, Fondue level is low now in my bloodstream. Let's try that. Save it. Okay. Does it change? Okay. Now I need to open the window because I will eat fondue now. Door. Tony recently mentioned that a day after she went in this, like the hallway, the staircase, and it was so stinky there. And this is like really big, so this is like another floor, and the whole hallway, like the staircase was smelling like this old cheese. Ah, yeah, that's the great. This should be pure alcohol here. Okay, here we go. Check. Oh no, I will drip on my scope. Okay. What is happening here? Is this a glitch? This must be only a glitch. And what is this? What is all of this? What is happening here? Okay, I need a clean clean project for this. I'm confused now. You're right. I can try. Okay, we have LEDs and we have, you know what I'm interested in? Oh yeah, input and output, that sets okay, what I can do is what I can try is setting, like, dismissing all this ADC stuff. Who knows what that is? ADC CLK, and set this here like ADC CLK equals basically, yeah, whatever, LED 5. Okay. Let's save it. Now it will complain about everything. Procedural assignment to a non-register. Oh yeah. Okay, let's do it. Counter. Let's put counter 5, whatever. Does it really matter? Wait, what? Hey, Sian. You didn't stream yesterday. What happened? Still unpacking Christmas presents. Oh yeah. Let's do that. Yeah, reg. Okay, here we go. Okay, let's try again. Oh, yeah. I watched a lot of movies recently. Yesterday I watched La La Land, The Wall. That's like an Austrian movie. Today I watched what's the English name? I think Deep Blue? No. Big Blue? No. A French movie with Jean Reno from the 80s, 88. First time I watched that. La La Land was actually quite nice. And we watched even more. What else did we watch? I'm not sure. I'm watching at least 2 movies a day currently. Okay. Syntax error. What is going on? Count as 24 bits. What don't you like about this? Oh, I have no begin here. Yeah. That's what happens. Here we go. Yeah, we have like, usually we don't have Amazon Prime, but Tony has a month free, and there is like some extras that you can book also for free, testing for a week, like art house. And actually we like the art house movies the most, which is basically a film rental. I don't know if it's German or European or French. No, I can't. But there are some, like, you know, some of the more sophisticated movies. Oh, Gottes Gemetzels. That's what we watched also yesterday. I don't know what's the English name. A very enjoyable movie. Roman Polanski. Original title is Carnage. Okay. Okay, here we go. Let's upload. Did I upload? No, I didn't upload yet. Let's upload. If that doesn't work, if we don't see anything on any pin, I will scream. I dripped up on my pants. I will now smell like cheese, and also on my desk. Jonathan Nolan. I don't know Jonathan Nolan, I know Christopher Nolan. Is Jonathan his brother or something? Peripheral, wait a second. Yeah, I saw that on the list of available ones, since I want to watch a sci-fi movie, and Peripheral was also there, so I might really try that. I will check it out tomorrow. That's a good movie for tomorrow. His brother, really? What? I didn't even know that he has a brother. Did I upload? Did I upload? Yeah, I uploaded. Okay, I don't see. What is happening here? What is going on here? How do I? Okay, let's do new project. New project. New project. FPGA bitluni documents. Okay, and not docs everything. We start from the scratch. Something's going on. Probably some configuration files. Mess. Jonathan was author of Memento, really? And Westworld. Okay. Interesting. Yeah, I like Westworld and also Memento. You know that Johnny. No, what is this Jenkins? This guy is the insurance seller from Groundhog Day. That's interesting. In another life, I would be I'd be like a movie director. Pushing the ADC to 11. Okay, what's the... NR? Was it NR? 9C? I think it was that one. Okay, let's go. New Verilog file. Top. Ok. And new physical constraints file. I don't know. How do you call the physical constraints file? Like the project, huh? Tester. Okay, here we go. And do we even need no, do we need like the time constraint, whatnot, or will it complain? By the way, where's our building phase? It's starved. Bitluni took holiday. Can someone try to rejoin him? Bitluni was bored of the movie talk. Here we go. Do 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 do. Yeah, it needs input. Complaining here. Okay, module. Yeah, let's just call it top. How does that work? I forgot how to write code. Did it close all the other ones? CLK output doubt 70 output see data. Let's call it like that. Or should we use camel case? Ha! Camel case it is. LBC CLK put ADC rack ADC CS. Here we go. Chip select output top, and then module assign. Okay, we can't use CLK rack count do FPGA no ChatGPT. Yes, I think so. I tried already. Yeah. Yeah, let's let the counter do also 70, huh? And then what is the trigger? Oh, let me just run ChatGPT. Okay, let's module. Okay. Verilog top module. Should we give it the prototype? Yeah. That let's put it like that. That uses a counter incremented by CLK to output and outputs the counter to ADC data. All other outputs 0. Okay, here we go. Let's do it. Ah, yeah, always. Pause edge clock begin. Okay, here we go. Assign. Okay, it does an easy job. Okay, yeah, that's what we want. That's what we want. Look at that. Okay, okay. This is our module. What? What backlog? What is going on? Adam? Adam, what is going on? Tell us. Plug in an ad for Adam Bryant here. What's going on? Okay, here we go. No valid top module. Okay, project configuration. General top module top. Okay. Okay, now it will complain about. Oh, that's the wrong file. Here we go. Okay, here we go. There is a semicolon. Did it use? Okay, it had the semicolon. Okay, here we go. Non-net, non-net, non-net. Okay. Now we need to configure make a constraint file that connects the input and output pins to sequentially numerated pins. Okay, here we go. Nah. What does it do? I need the constraint file. Oh, pin assignment. Top instance, okay. Constraint. Okay. That's a different way of doing that. So the go in example, but do you see that? Do you see that? It actually does something, huh? So it's not very stupid, I have to admit. But that's not what I'm looking for. Okay, I will ask it. Does it also work with go-in e? Ah. The answers always sound like ChatGPT learned in the whole, memorized the complete book on Verilog and Okay. Okay. A little bit of cheese to power up my brain. And then what is the input CLK? Where is this coming from? Okay, let's clone it from the other projects. Can I open the other one? Okay. Oh, interesting. There is a second clock defined. Let's clone that one. SDC file. Oh wait, let's add an SDC file. Timing constraints, okay. Okay. Let's add this. Xtal. Is this Xtal in? Get ports Xtal in. What? Is this? Nah. Yeah, that's Xtal in. Okay, we need to clone that. User button, reset button. We can clone that because that's like hardware related for that one. Xtal in, and the top is Xtal in. Okay. Computer science learning guide. Oh, then ask question. That is a quiz. Give an example what. You can also use ChatGPT to explain it to you. If ChatGPT is knowing anything, then okay. ADC previous errors. Okay. Okay, let's clone the other ones as well, and I hope that this is LEDs. What is GCSE? Let's clone these locations. Physical constraints file. Maybe I should. Really? Ah. I have no clue what that means. So, who of you thinks that Tesla is going down? I hope nobody of you bought the stock recently. Ah. No. I'm not shorting anything. That's too hot. I think that's like, I think that Musk is just manipulating the stock right now. I have no clue what the internal things are right now, but he acts like he wants like to tank Tesla and probably rebuy at the lowest price. I have no clue. He apparently, his Tesla stock was involved in buying Twitter. So it's part of the contract for the banks or whatever. And now, yeah. And that's like a huge pump and dump scheme right now with, he probably like just wants to manipulate the stock as much so the loss that he takes with Twitter is somehow compensated. And probably he knows he has some bad news about self-driving capabilities. Yeah, let's do that. Oh wait, I sold my power bank. I need a new one next year. Another review is incoming. No. Okay. I'm slow at coding right now. Yeah, reset button. Let's do. But what is this? Clock name. Xtal CLK. Now I need to save everything. Yeah, they probably would. Non-net. No, unfortunately not. It's a super simple one, super cheap and super simple. The only benefit that it has is that it's cheap. And it drives smooth. Anyone needs a diesel car? I'm selling my like in 2 weeks. I still need it for a long range drive. But then I will sell it. I try to sell it for 500 euros or something. I mean, you can still use the tires, they're quite new. Tires and I don't know what else. Basically everything is breaking. Accumulator. MAR, MDR. Okay, something needs to be include path, top, wait, generate SDF file. No, SD is false. This is something else. Unused pin. Okay, let's see. Concurrent. What's concurrent about that? To non-set. Physical constraint. What am I missing here? What is this? Should we ask ChatGPT? Okay, yeah, but it's not. It's like ADC data. There's no concurrent non-net. It's also not non-net. Oh, I'm lost. Ah, okay. I need a brain. Who of you brains sees the problem here? Okay, let's try that. Wait, we can also remove that because non-register, non-net. Oh. Oh, interesting. Okay. So maybe let's do that because, oh wait, it's a register and it isn't clocked, so we can only assign it as a wire. Okay, here we go. No, still not? Wait. Oh, wait, that's an error. Okay, yeah. And then don't do it. It's an error, okay? Still error. Oh. That's not assembler. Okay, we need a new... this is the wrong ADO FPGA docs myself. Okay, here we go. Ah, something changed, huh? Wait, do we have a clock here? But why? That shouldn't be a clock. What is this? Yeah, but it shouldn't be there. It should be 0. What kind of pulse is this? What did I assign here? Let me check the other pins. Yeah, we get like 0, 0, zeros, but these outputs, do I have like wrong pin numbers? Okay. Let's think about it. Maybe my configuration here is wrong. Ports. Wait, I have pull mode up. Maybe I removed that. No pull modes. I don't care about the modes. That's translated from German. Einen geschenkten Gaul schaut man nicht ins Maul. Yeah. Okay, so ADC data is output. Why doesn't it count? Counter +1. Yeah, sorry, Looney can't do that. Yeah. One and a half hours in, still not checked off. Wait, that looks like it's a clock. I have the wrong pin assignment. These are the wrong pins. This is like pin 0. This is like pin 1. What is this? Should be, this is ground. This is for fool. This is like, you see that? You see that? You see that? So we are outputting the counter to data pins, and it appears like this is a higher significant bit. This is the lowest significant bit because we could get 13 megahertz, which is half of the actual clock, which is about right. So this will be 0. This will be 1. But why though? Okay, let's check again. that was a mean hit towards, where is the, I try to find SciPad. SciPad, speed. Okay, let's check again the pins. Let's check again the pins. I thought maybe I have mirrored my footprint or something. It's upside down. This would be terrible. A terrible solution. Oh no. Specsavers? What is Specsavers? What? Huh? 40% influencing my judgment. Okay. Let's see. 48, 49. 48, 49. (48) and 49. (48) and 49. Okay, let me check KiCad. Ow, why is my... What is my PCB? Where's my PCB? Okay, let me check. Oh yeah, this is the PCB, okay. Ah, dead. Dudes. Don't... Okay, I started Elon Musk discussions. These discussions are... wait. So, what did I do? 9 and 10 ended being... What? Oh no. Okay. Okay, friends. I see. Okay, we get on pin 9 and 10, we get like, or I get on 10, I get 1. On 9, I get 2 instead of here. Do you see this a potential source of that problem? If 9 and 10 is here, and I get here 1 and here 2, do you see a potential cause of that? Too much cheese? Okay, I tell you what the cause could be. The cause, it might be that it's just 90 degree, like 180 degree rotated. Look at that. 10 is 1, which is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. And then we have like 5. Oh. My board. Okay. Okay, let's confirm. Let's confirm my mess up on the board. I show you. Oh no. Okay, I need to reorder the board instantly. Oh no, I don't think I will get one in time for next week. Nobody works. Okay, I must try to get it. Okay. Wait. Okay, wait. No. I just need to rotate the controller. Yeah, the worst would be if there are multiple 5 volts pins that I would connect on the board right now. But there is only one. So this is our light. Oh, and that we don't have a ground connected to another power pin. But basically, let me turn off the silk screen, or let's take a look at the copper. These are our. But oh wait, where's the pin out? Here. Oh no! Oh, the USB connector is here, and the HDMI is here. I looked at it upside down. Okay, now. Okay, let's see if we can release the magic smoke by rotating. Okay, it's not mirrored. Okay, friends, let me do the real talk. It's not mirrored, okay? I didn't mirror the board. I might have rotated it by 180 degrees, and by coincidence, we didn't break anything yet, but we didn't mirror it, okay? Okay, so let's continue. Specs. Magic smoke time. Okay, let's do it. Let's do it. Power off. And then clearly against my own specifications. No, 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 no. No botch wire. No botch wire. No botch wire required. The only wire required, I just plug it in this way around. No, 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 no. And now power it up, okay? But not like this. Ah, shit. Okay, let's smoke or not smoke. Okay, okay. Let's vote. Let's vote. Smoke or not smoke. Smoke. Yeah. Ja, nein. Smoke or not smoke. You vote. You vote. I hope. I might have rotated the individual connectors as well, because these are like two. Yeah, yeah, yeah. Okay, if we look at the schematic, oh, this is the wrong schematic. What? These are okay. Wrong screen scaled here. So these are like individual connectors. So I might have rotated like one of them. I don't know. I can't tell. I don't know. I don't know. Hey, Dave Odessa, you're right for the vote. Smoke or not smoke? I didn't mirror I didn't mirror it. Oh, and I also have the ground connected here, so this is like chance. And okay, now let's see if it smokes. Okay, I don't smell anything. Oh, Smith, thank you. Did you get your salary today? Thank you very much. Okay. Okay, where is my, how do I end the Umfrage beenden? Okay. So, now we can test. Now we can test if it does what it should. And then I should order a new, we should fix the board and order a new one, because this is really embarrassing. Okay. Okay, now we have a proper ground as well. Okay, this is one. Is this, yeah, this is two. This is 3, 4, 5, 6. Okay, I need to zoom out. And 8. And this is both grounded. Nice. And this is power. Woo! Okay. 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 Let's fix it. Let's fix it. Okay. We can check off something of our list here. Okay, we can check off Okay, now we need what? The stream is still not over. I still feel like streaming another 1.5 hours. No, 2 hours. 2 or 3 hours. So there is still a chance. Okay, let's do fix and reorder boards. Okay, we have a new thing on our list now. Now we should also, okay, this is now a cool test project, and now we should also test these things. So clock and let's just test it like that. But ChatGPT, oh, by the way, who missed it, ChatGPT did the code for us. So here, charger cable. Here we go. So ChatGPT did the code for us. Now 9. Hey, Chris. And counter 8. And counter 7. Wait, 8 and 9. Yeah. 9, okay. Here. Chip select should be the rec. Here we go. April Fools? Which one? Repack smoke back in an IC with a syringe. Okay. we have the parts for that. We have everything in the lab to make that video. You remember me? You remind me of that, like one stream or 2 streams in advance before April. Like in March, you remind me of that full sprank. Please put it in the Google Calendar or something. I mean, you are admin. You can even probably create an event for that in the calendar on Discord, so we don't forget. It's a cool joke. We will make it sophisticated. We'll cook a soup or like a canister. Oh, yeah. We just need to print, like label this with an IBM logo. And this like a IBM refuel gauge. We just need, like, I mean, I remove that paint, or we can just paint something on top of that, and that will be easy, like an IBM logo, magic smoke, and there will be, like, we can make a story around that, like this canister is from like 73 or something, 1973, and they are really rare. So the story is that it's like this is like an empty can already, and there is only a limited supply in a bunker somewhere, and at some point we need to reinvent new processors like the light-based, the photo-based processors, because these ones are limited only. The magic smoke is an isotope of you take what is the bismuth? Bismuth is like a mysterious element. We take like a bismuth and some what is it? Did someone do a short on that? What is? Oh no, I can't open. Oh no, I broke my chat now. I broke my chat window. Ah, docs. Anyone tell me please what that is about? And thanks Henrik for the donation. So I have quite some ideas. Obscure unobtainium. Okay, unobtainium. Okay. Okay, so the video is like the idea is almost developed. Chinese you. Yeah, but then it doesn't like match with the IBM story. We can maybe salt in a little bit of truth, so it's believable in the first place. Like make a STEM course of that. Okay, let's start new chat. Make a script. Make a script for a short YouTube video about refilling the magic smoke into a broken IC. Broken IC, and the magic smoke is some kind of isotope of unobtainium that is unobtainium that has only a finite and I own a small amount. Let's do that. Here we go. Okay. Hello and welcome to another video on fixing electronic components. Today we're going to talk about refilling the magic smoke into a broken IC. So what is magic smoke and what that we are talking about? Well, it's a special isotope of unobtainium that is used to repair broken ICs or integrated circuits. It's a finite resource and I'm lucky enough to have a small amount of it. Now the magic smoke is essential for fixing. Okay, it doesn't like it didn't comprehend properly that the magic smoke is like the essence of every IC in the first place. And so we have to like to fix that narrative. Okay, it has steps. The refilling magic is to broken IC sometimes be difficult. magnifying glass. Should be able to find it. Okay. And I mean, that might justify purchasing that infrared camera that Mike is owning. I saw that in real life. The camera is so awesome, and it's not very expensive either. So we can make it like a tutorial of spotting a broken IC and then refilling it. From the device is usually done with soldering iron and some tweezers, but okay, gentle. Prepare magic soap for injection. It involves carefully measuring out the correct amount. Oh, Dominic, thank you. I hope you have also a nice vacation. Now it's time to inject the magic soap in broken ICs. Done using a small syringe and steady hand to inject magic soap broken connections within the chip. Finally, you can reattach the IC to the electronic device and test it to see if it's working properly. If the device should be good as new. And that's it, refilling the magic soap. Seemed like a daunting task. Okay. So I can rewatch this stream. I don't know if I can remember which stream it was. It was like a New Year's, like in between the years stream. All planets are in a row. Oh, maybe we can hint off that's an April's Fool joke. Like refilling is only possible at one day in the year. One specific day in the year. Like, give it a small hint that it's April's Fool's Day. Okay, now someone will steal my idea. We need some extra work to do that. Like X-ray video of okay. Now X-ray of IC. Okay, we need to take like something like that image or render it. Let me check if we can find. Okay, we need. This is still on the PCB. I need a good image of an oh. Yeah, but we don't see any circuits. I mean, we can fake an X-ray and basically show how it's like injected into the traces, back in the traces. Imagine that. Imagine that. I give it away now, so unfortunately you won't be able to enjoy that anymore. Look at my smile. Look at my smile. Like, look at my cheeks. They're pinned. They're pinned to my skull here. That's how hard I'm smiling right now. This is like, this is fun. This is fun. That's why I want to be a director. Plenty of ideas. Okay. Let's not spoil everything. Yeah, but was it IBM? When was IBM founded? What? Seriously? What? Second World War? A little bit more of story putting in there. It was basically, it was basically, yeah. The true cause of World War One. No, when in World War One, they're fighting not because of that what was it? The royal that was killed somewhere in Zagreb or where it was, but it was about getting the recipe or the source of the unobtainium. Let's not discuss World War II. I think as well, because that's like, I mean, the reasons for World War One are less like impactful than doing it with World War II. Don't mention the one. No, it is like I think we can do jokes about like Hitler and Nazis, but doing like jokes about that, there are people that were like all the Jews and all the people that were basically harmed by that history. You don't want to make a joke of that, so I don't want to be like touch a subject like that. But World War One, the reasons of World War One were like strange to me, strange enough. Well, it wasn't targeted towards like a specific. Okay, now talking about religion and yeah, this is like which law is it where you talk long enough? Sometimes Hitler, you left TT. What? How? I never leave. Oh no. How do I leave? That's Discord. Discord crashed. Foo. Okay. Am I back? Yeah, I'm back. Discord crashed. Who knew? No, not drained battery. Basically, Discord crashed. Okay. Let's focus on that. How do I fix that? I just need to move everything because I need to fix. Oh wait, I wanted to test the output. What? Properly scale. Okay, wait, did I program already? Okay, I think I reprogrammed already, and we wanted to see. Wait, is this chip select or is this chip select? This is, okay, so small, big, biggest, small. Okay, so 9 is 10. 9 is bigger than 10. 9 is bigger than 10. In the code, CLK. Okay, this will be 9. 9 is bigger. Chip select. This is 9 and this is 10. Okay, and this is 1 to 10. To 8. These are the pin numberings. Okay. Oh, you don't see anything. Whoop. Really? Yeah. Okay. It's. I mean, at some point you couldn't like. It's not allowed. Like the swastika isn't allowed in Germany. It's a like forbidden sign, because you could glorify that. Of course, like there is a gray zone with art and books or historic books or something like that, but historic movies or so, but you wouldn't be able like to print a flag, I think, or in this case on a model plane you couldn't put on like a swastika there or whatever, or Iron Cross, even maybe, I don't know, because some people might be able then to glorify that, and that's basically, it's a small sacrifice to not have models like that. But I think there's still like models around. I visited a house that we wanted to buy last year from like old guy. He had weapons at his home, so he went to like this elderly home, and there were still like weapons, and he had like models, airplane models, and so on. And I think there are some historically accurate models as well. So some kind of militia fanatic. Superior Spitfire, I don't know what that is. So many ways to fail a swastika. Yeah. Oh, okay, yes, sorry. Yeah, we can cross off something of our list. Sorry about that. We tested CLK and CS. Okay. That's that. Now fix and reorder the board, which we will do now. Unfortunately, I don't want to reroute it because it's like, yeah, I bet there were like a ton of, I think, a ton of people when Germany were losing the war, that they didn't want to be identified as, oh, I want to drag that, identified as Nazis, and they basically hid everything, like the uniforms, and got rid of everything. That's what disclosed them as. How do I drag that? I thought I can drag. Oh wait, let me drag. Oh yeah, that works. Shoot. Okay. Why didn't that work? Doesn't it work? No, it doesn't want me to drag that. Oh no. Foo. Okay. Let me remove that. That's the. Oh, you get also late deliveries like that. Man, this is like crazy. That wouldn't be typical. I think the latest I got was 8 o'clock here in Germany. Maybe in the cities it's different. I can't track it. I can't track it. I need to move it and basically what was select with select connected, select how do I select the whole track? It was some kind of letter. Drag. Oh, come on. Why doesn't it drag? Should be simple. Doesn't want to. Doesn't drag. Okay, and we need to move that stuff down there. Is it centered? I have no clue if it's centered or not. And that stuff. Like that, so it won't complain about out of bounds stuff. Like that. Okay, now I need to. Please tell me which button is select all trays. Maybe like, oh, wait. Yeah, I can use drag. Drag will work. Funny. What? What's the grid size? Okay, here we go. Why? Why is it going to the other side? Stop it. Come on. Okay. Okay, I leave it. I leave it there. Same. Stop it already. Did it connect? Yeah, I hope so. Yeah, might be, but okay, let's try again without any info. Nah, it's because it's pain in the ass. It thought, ah, it's too easy to do it in the front. Let's do it in the back. Wait a minute. Oh, there it is. I thought I made a mistake. I did a mistake. Okay. I didn't think I have to rewire. This is stupid now. Hate it. Okay, let's use the rewire tool here. So what is going on? What is that? Huh? Is it easier to do it in the back? What do you mean in the back? Oh. Oh yeah. Come on. Here we go. This one. Look at this. Why? It probably takes the last state or something and auto routes. Ah, yeah. So you're adding this to the quotes again. You always find funny quotes. Okay, what did I miss here? We get some serious power here. I got the power. Boom, boom, boom. Yeah. It's going directly underneath. Yeah, I forgot. Okay, come on. Let's fill it. Let's wait. No. What did I do? Okay, here. Zones. Fill all zones, B. Okay, here we go. Fill all zones. And we need to add a version. Do we have a version? Version, wait, oh no. Is this really SVG? Oh no, I should, let's just clone that. So the distance here, okay, I try to, thankfully, next version that I will do will be version 1.11. But now I need to move all this thing here. Or to this side. Okay, here we go. Yeah, it's still 22. And now we need some wires. vias, vuyas. Here we go. Oh, I changed the positions of the holes now. Square hole. Here we go. Does it fit here? I don't want to mess with the silk screen. Oh man, this will never work here. Okay, okay, no, that doesn't work. Let's drag it a bit over here. Let's drag all of it over here. Let's B and let's refill. My plant isn't in my view. And look at this. This is how I need to work with my plant directly in my view. But it survived. It survived me being gone 2 weeks and not fueling it. This is how you call it, refueling. Refueling my plant. Here, let's kill some of the antennas. Let's kill some of the antennas here, shall we? Ah, here we go. Kill antennas. This, yeah, there is all hope lost here. There is some silk screen. What is happening here? This is stupido. Okay, let's go. Huh? Yeah, H2O. H2O, refueling using H2O. Hydrogen dioxide. Hydrogen dioxide. No, wait, it's dioxide, How do you say it? Oxygen dihydride, monoxide, dihydrogen monoxide, oxygen dihydride. It's not wrong. Why can I want to drag that? Why don't I drag? Drag. Drag. It doesn't drag. We could like make it drag. See you later, Dave. Oh, wait, this is broken. Ah, that's why it didn't want to. Yeah, whatever. Oh, that's interesting. An interesting question. So, let me finish that power line, and then I will tell you my strategy. Okay, I want to this corner here. Let me drag it. Drag it. No. Foo. What is that? Go away. Okay, drag. Okay. So no sharp corners, so that the electrons don't fall out. The strategy, my strategy, I don't know if it's the right strategy. I'm not an expert, so I basically, you see, there is like this infill here, and this infill ends over here next to the, because there is a trace or whatever reason. And here it might be also cut because of some traces on the other side, or it's a narrow passage here. So we have some kind of like antenna or whatever. And since I have like on both sides ground here, I can connect it to the ground plane here basically to not make an antenna. Like if I didn't have this via here, that would be an antenna that would probably ring at some gigahertz range or whatever, because it might be like charged by whatever, by the signals next to it, or you have some kind of AC coupling here. And I try to put us, like if I have like a ground plane here, I try to put the ground wires at least at the corners. Usually you would put them randomly like all over the place here, but at least at the corners here. So here would be a nice spot, and here would be a nice spot, and here would be a nice spot, just to break any loose ends. So I just tuck it in place. So we don't have, and then also one strategy would be to put the wires not in a grid like this, but put them someone randomly, so you don't have resonance, any sort of resonance. That's just an educated guess. I have no clue. I'm not a designer. I'm not an expert on this. Space Invaders. Okay, let me put, because this is a mounting hole, is it? I don't know what it is actually. Do I have a hole here? Yeah. Okay. I just put it there. So we have some mounting holes here. These are like huge mounting holes. Yeah, that's my mounting hole. I'm too lazy to do proper mounting holes, and they end up looking like that. I show you. At least at Isla, they are not plugged. I don't think that anyone can. I hope I don't short anything, but here's an example. This is, I think, 1.5 millimeter diameters here. So this would be one. There is one. This is on the dot. Though I had to shift these because of some traces. So these give me the slight opportunity to not only like clamp it on the corners of the board, but also like put some poles on the 3D print or whatever. So basically this should be, I think it is 1.5. No, via diameter 2.2. Okay, so it's even like 2.2. So you could, if you print like a pole, you have a 2 millimeter pole that should fit. But then you have also to know the exact placing. I don't know if it is. It should be right. Okay, more vias though. I want a via here. But here is a ground. Let's put one here. Here. This looks like it would need something here. Some random vias. Here you go. That looks like it could need some support. Even though here is one. Did we miss anything on that board? I don't think so. Oh wait, what is with that one here? There is nothing. I hope that this will probably mess a little bit. Okay, B, and it will refill. And now let's check the DRC rules. Yeah, warnings. Oh no. Do the whole PCB in vias. You can. You actually can. Like set a region that's filled with vias. Okay, so what do we have here? What does it say? What is going on there? Eh? What was it complaining about? Unconnected end? Seriously? Ah. What track? What is that? What is going on here? This is 6. Wait, what? What is going on? Come on, 11, 12, 13. 1, 2. Oh, this is the silk screen. Yeah, that doesn't matter. Silk screen. Okay, that is okay. It will be clipped. Silk screen is okay. This will be, but this one here. Which one? This is unconnected. This one here. Wait. Ah! There is a short connection. Okay, here we go. Now. Okay, it's only silk screen. Unfortunately, I don't know how to fix that because apparently I'm not able to clip that. It's an imported thing. Yeah, I think this is done. Let's check the view and then I will reorder that. Okay, we have a display and USB switched and everything is moved. And we have FPGA here. I hope that's all right. Nice. Okay. Let's order that and I'm done with one more task. Now that is correct now. I just had to move it, shift it a little bit. Get started. Select file. And now by the way, my design for that free random shuttle for ASICs. So I'm still like in tiny tiny tape out 2. I'm still with my 3 designs in that shuttle, but I committed one of the designs in these other ones that where it's like a big design, and I didn't make it in the pick of the. I think it was like chance of 33%, and my project wasn't very convincing there, so I didn't get in that round. But there is another one in 3 days, another deadline. So, but I still hope that I will, wait, this is ASIC, FPGA, that I will be able to get an ASIC quite soon. I hope we make it and it turns out to be a cool schematic PCB, okay, öffnen. Okay, here we are, design rule, and I will order now. I don't trust it to check out beautiful boards Blitz and oh, if you need to order, change, PayPal, confirm. By the way, let me show you. So, because, okay, beautiful. I hope it doesn't. Okay, beautiful boards budget. 3 boards cost $11.32, free shipping. Is there? Oh, and there is also a donation, Kaike donation. If we remove this, this is like, I don't get any sponsorship. That's the price for the budget board. Yeah, incoming, and here enter coupon code bitluni. This coupon code is only until the end of this month, so you should doxing. Okay. Wait, I don't need to pay anything anyways. Oh shit. Okay. Okay, what time is it? I need to find it later. Okay. F it, you get discount if you use bitluni as okay, here we go. Estimated dispatch 4th of January, okay? Every single time. Yeah. No worries. I will as soon I will edit it out later. Okay. Yeah. However, back to our goal list. I need to buy a house and move away from here. Fix and reorder boards. What? The Eisler? Cloudflare? Yeah. You know what's funny? How you were talking about Cloudflare and how awesome it is, and then like, I don't know, a week later or something, Cloudflare completely broken and half of the internet was offline. Except for me, because I don't use Cloudflare. That was funny. You don't rely too much on one company. Don't put your eggs in one nest. All your eggs in one nest. How is it? What's the saying? Is it the English saying as well? Okay, splendid. Basket, okay, put your eggs in one basket, okay. Okay, let's go. Slastic. Okay, now let's read the ADCs, shall we? Verilog fine. Okay, now read sample and add this to the LED, and then we will basically move it again. Okay, ADC 8. I call it ADC 8. Okay, now let's clone the old code. Or now let's rewrite it. ADC 8 inputs CLK what is that? Inputs 70 ADC DIN output rec ADC CLK output rec ADC chip select, then output rec 7. Let's do an 8-bit sample output rec CLK. Okay. See, it didn't. There is no reset. Is there any resets? We don't care about resets. Nah, not yet. Okay. Okay, and module. LastPass? Why? What's wrong with LastPass? Hey Ray. So Chris, did you miss anything? We fixed the boards. I don't know when did you leave? So we had to fix the PCB and reorder it. Oh wait, LastPass, that's like the password manager that was like completely, the database was stolen. Yeah, I don't do that. I trust only Google with stuff like that. Everything, yeah. I only trust Google, but if Google goes down, everything goes down, so. I don't even know my passwords. I use the Google generated passwords because I couldn't trust myself using like a proper password for every like an individual password for every platform. Okay, now let's clone the counter from top like that. Let's clone the counter and basically let's do a counter. And what clock do we want? We get 27 meg. Bit 1. Okay, so let's test 27 megahertz. Oh, we had like yeah, I think if counter equals 10-bit, let's say 270. Up, that's D. Begin counter equals 0. And then we had, what is this clock? We had the, yeah, we just repeat everything that we did back then. No, wait, we have already the ADC clock. Now that should work, huh? ADC clock is basically not ADC, C, okay. C, and else begin. Yeah, we can do everything. Wait a second. Shall we just... No, let's do a second counter. Rec, and then do bits, bit count, current bits, whatever. It's 4 bits, 16. So there's the ADCs are shifting always with, there is a shorter version, but 16 is the regular. So we need like only 3 a counter. Welcome back, Max. Current bit. Okay, current bit. However, this is assigned. I have no clue how this is assigned in the beginning. How do you assign this? Is it uploaded like with the bit stream? The initial value? I mean, it's a D flip-flop. And you have like to preset the D flip-flop with the 0 somehow. Or is it creating a new circuit there? Just for the initial value. I think in ASICs, this isn't even like working. So if you're designing with ASICs, I think the initial value is not present. Probably. Oh yeah, the PCB order, the KiCad and PCB, yeah. Now, current bit, we basically clock, we just do current bit and conveniently this we can do 16 clocks here each, and this will be basically current bit. I hope it's high or low, whatever. So we have the clock set, counter, chip select, else for what values? Oh wait, we need 5 because we need, it's 16 clocks, but it's like low and high, so we need 4 here, 5 bits. We have 32 states, and then this. Now if let's just say current bit is basically bigger than, I don't know, 4. Then we will set ADC chip select low, else ADC CS will be high. Oops, we need 1 be up, 1 be 0. Okay, and this is also 5-bit decimal, and this is 10-bit decimal. It will otherwise complain, and this is 1-bit 1. We can do a decimal, doesn't care. DDR? DDR? What do you mean? Double data rate? No. No. You mean always on the clock, low and high clock? Yeah, let's see how it fails compiling that. Oh wait, we didn't connect, we didn't instance it. We don't even read anything. Yeah, let's ignore the warnings about that. And now we basically take ADC 8, ADC. This is the instance, and what's the? Is it CLK? Is it all the same? Yeah, ADC sample, clock sample. Oh, I used small here. Chip select. Okay, let's keep it the same so we don't have to. It will auto connect that. CLK. ADC data. Is it data or DIN? What did we? Data, okay. Oh yeah, this will be in top. This will be also input. And it's not a register, and this is also not a register, and also not a register. And this won't be that. Am I? Positive edge. Current bit. Yeah, no, I'm not clocking in anything right now. I'm just setting the chip select, and I want to generate a clock and the chip select for now, and then I will read in. Oh, you mean on DDR? Yeah. Yeah, but we don't do that. I think there is a mode, a fast mode on some of the ADCs, which clips few of the bits, I think. So you can get faster conversion or something. But we don't do that right now. ADC data, let me just complete that. ADC, what is CLK, ADC, CS, then we have now per toggle of clock. Just see now, does it compile? Yeah, I just want to instance it so we see if it's just wait a second, Chris. We don't do anything right now. I think I will just do it on. I can use another trigger here. Always add and then use basically ADC clock as that to clock it in or on pos edge or neck edge. Or do it inside of here as well. So I could do both. It might be easier to read to put it in another trigger. But I have to check the datasheet first and then let's see what we can do here. Thinking, Matthias, thinking. bitluni, thinking. This is that. Yeah, sample clock and sample. Sample clock. Shall we rec sample? Yeah. Ah, stop it. Sample CLK, okay. Pull. They do. Is this the right order? Is this the compiler? Fan spin. Yeah, clock first. Yeah. Okay, here we go. Boom! Error. This dialect, okay. So let's use system Verilog, or should we? Okay, come on. Let's leave it with. We are still compliant with it. We won't be compliant soon, but let's stay compliant as far as possible with basic Verilog before we some sample, so smapple clock ADC CS ADC CLK ADC data. Okay. Saved. Clear. Recompile. Error. Near else. What's going on? Oh, else and. Here we go. Boom. Sample, yeah. Okay, let's do it. Sample not set. So let's go basically always here. Basically 8-bit 0 and that's sample and sample clock. We can do it whenever current bit is 0, we can change the sample clock. When it turns 0. Hey, Dutch maker. I feel lazy 64, I feel left behind. Peoples. What? Non-sample. Non-net sample. Wait, we need to... Oh. Let's wire it, huh? Here we go. Wait a second. Was it successful? It was successful? Really? Okay. Okay, my dudes, let's program it. Is it writing fresh? Yeah, it's writing fresh, flash, I mean. Let's get a second probe and see how our clock and trigger warning. The steps that I planned for our checklist are quite huge. Now, like getting sample read is quite substantial. So, okay, let's see. My Sid is feeling sad. You are a jokester, Mr. Dutch Taurus. Phew. Okay. Okay, I need trick 17. The German saying is Trick 17, Trick 17. Look, this is my Trick 17. When probing stuff. Here we go. That doesn't drag off the table anymore. Let's go. Oh, you want to see that, huh? Let's turn it on. Let's not take it apart. Let's turn it... Oh, it didn't work. Why though? Okay, these are all poles high. Let's see. No. What is this? Duct tape. Wait, what is the voltage here? Is this some kind of joke measurement? What is this? What is this? 58 volts? What is this setting? Is it broken? What is this? What is this probe? 10 times probe? What is going on here? Oh, this is 2 and this is 1. 1 time probe. 10 time. Hey? Okay, I try to... Trying to find out what... It is certainly not 30 volts here. Probe. the connection? Did I switch something? Nah. It's not properly detected or something. No, it says one time, wait. Oh, now it's set right, okay. Okay, but why don't we see... Nah, it's not 30 volts. Oh, nice. We get 50 kilohertz. Why do we get 50 kilohertz here? Did we want 50 kilohertz? Why is it 50 kilohertz? Ah, come on. Let's calculate what we are doing here. Okay, let's analyze our stuff. Read sample to LED. There is no step in between make CS and clock work. This is like too much at once. That requires too much at once. We only yeah, it's 10 times probe. Channel. Okay, here we go. So 27. Oh, yeah. 27. We divided by, so it is 100 megahertz, but we need like one clock cycle to set it up and down and so on. So we need to divide it by half that much, so 135, then we get a 100 kilohertz sample rate. 100 kilohertz should be right, huh? Okay, and now... Oh, yeah, there is no increment here. Where's the increment? Where's the... Oh, here is the increment. Okay. Current bits, it's 5 bits. It compares. There should be a chip select. I don't see it happening. Where is my chip select? Okay, this is the signal. Chip select, is chip select at 9? Okay, I check if chip select is at 9. Chip select is at 9. ADC, chip select, chip select. Anyone sees the reason why that shouldn't work? Current bit. Okay, let's try. Let's try something else. Let's try 4. It should be. Okay. Not 100 megahertz. Yeah. Here is your 100 kilohertz. 100 kilohertz works, but I don't see anything at the chip select line. Chip select not worky. Okay, let me check that. Chip select. Okay, current bit. Let's make it 1. There might be. Let's not use. $19.2. Yeah, I'm probing the right pin. I spotted. Oh, wait, it might be like the probe not really properly connected or something. I hope. I will test if I can see the other one. Okay. Let me check if the probe works even. Oh. What is that? What is this voltage again? What is... Oh, come on. No, it's switched to the... Yeah, you can see. Okay, let me set up the scope properly. This is switched again to like 10 times and 1 times. Oh. This is millivolts. Two volts. Is there? I don't know why this is, but this probe really sucks at being a probe. Oh. Oh. Now it plugged. Didn't I plug it in correctly? Okay. Let me see. Ah. Okay, this is for 2 volts. Let me probe that. Okay, let me switch to that input. Okay, let me take another probe. I have no clue what's going on with that one. Ah! Yeah, I'm suspecting my code, and at the end it's just an issue. I have more probes. More. I give you a better view so you can see what's going on here with my fondues. Okay, so this is the clock. It should still work. Here we go. Oh yeah, it's shifted. Because... Okay, here we go. This is the relative. Aha! Now we set the trigger. Yeah, let me place it properly. Now we need to set the trigger to that one. I need to check the other one. Okay, trigger source is 2, and then just set the trigger level here. Okay. Okay, now let's restore our code and code what we needed to code here, ADCs. That will be just okay. Programmer. Bloop. And that's about it. Okay, here you go. Rip. Okay, now let's check the timings for the ADC. Oh, someone asked me. Who asked me which IC it is? I will tell you in a sec. Just to log in. I have 1 hour to go. Okay, where is my orders? Order history. Here we go. 160 euros. Is this the order? Yes. Oh yeah, it's a max. I think it's a max. This is the part number that I'm using. I think it's 16. It's 8-bit. Yeah. 3. Either it's the max, this one, or let me check the other one. No, that's not that one. I think it's max. Oh, so we can actually use it at 3 megahertz. But this 3 megahertz is like a topmost, whatever. Let me check the data sheet now so we can actually do the right timings now. Okay, blah, 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 Mr. Freeman. Here we go, timings. Okay. Oof. Yeah, CS, that's basically We set it low at first, and then here is it for you. Is this, yeah, that's the throughput 12-bit devices. Is there 8-bit devices? Yeah, the 8-bit, it's also compatible with 8-bit devices, I think. They're all cross-compatible, so... Here, 10-bit, oh yeah, okay. This is better, 10-bit, 8-bit timing diagrams, which are basically similar. So we get CS is low at shorter than, and basically what we want to do, yeah, this is, it doesn't matter since we get the highest significant bit first. This is a leading 0 because there are also ICs that get signed values, so you have a leading 0 always. So actually you have like 9 bits with sign. We can take that and convert how many bits we like. So this will be compatible with both, and you basically get more detail in the lower significant bits. It's a quite smart interface. I like it, Picasso. Okay, so chip select is down first, so let's make it like that. Whenever current bit is shorter than, what do? We start with, oh, we set it. What's the timing? We might need to set it. Okay, it requires, if you look precisely, it requires us to do it like that. So we will set it here. So we get like the clock will be inverted. The clock will be inverted, so we get not. So at 0, we get high. This is our 0 here. 0, 1, 2, 3, blah, 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 blah. This is 0. And chip select is set to 0. And it will be here. So that's like 27th. Okay. What? Good for way to noise? What do you mean? It's a sacrifice I'm willing to make. I don't know what you. Are you delayed? And I don't know what you're talking about right now. What noise? Noise of the. Okay. Yeah, we won't see anything like happening on the... We should see chip select to go down with a high clock. We can check that. Oh, going low with a high clock. Yeah, that's that. And it's staying there for 2 highs and 3 lows. Okay, let's check that. Yeah, that's oh, you can see. So what I'm doing now is how do I can't move this. This is stupid. The viewer is stupid. Okay, so since I'm doing on this edge here, we have 1, 2, 3 lows and 2 highs. Is it right? Yeah. So this is my output. Oops, only 15% left on my left ear. That's okay. And the viewer, no. Not talking about you. Okay, when do we read? When do we read? So while we are already here, the hamburger, oh, what? You saved my life. Okay, so we set it here. This is high impedance. So on the first high, we read. Then we read before. Wait, we read always here. Chip select. Okay, so 27. This is low, and this is where we clock in our... Oh, this... Sorry. This is where we do our current bits. Well, this is not the bits actually. So if current bit 0, no. At what edge do we read? Going high, so it's low. Okay. If current bit, if not current bit 0, and okay, so this, and before that, if and bit is bigger than is greater than, we start, this is 0, 1, oh. Oh, bye, Max. I wish you also a happy new year then. See you next year. In Germany you say Guten Rutsch. a nice slide. Okay, and this is where, oh wait, okay, we clock it, we put in the highest bit. Let's see. Okay, when we have, this is if begin and else and begin and here we go. Oh, do we need to stage it somehow? We need to stage it so the rec. Yeah, let's stage it. So we have how many bits do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. For whatever reason, 13 bits. So 0 to 12, because we have the sign. So this is in bits in. Yeah, that doesn't matter with the 0. Okay, bits in. Basically and else and begin. Now we need equals and begin and oh, this is, yeah, we can, wait a second, we can set this here. We don't need to set it always. So we do it like that. We do only change the state and then we stage the bits in. So bits in will be staged to sample and we only use the highest significant bits, which will be 11s because we ignore the sign. 11, 8. was this sample? This is smaller and there we go. Sample CLK 0. Whatever. And sample CLK. We just need to trigger it somehow. Okay, simple. That should read in. No, that's not reading in yet. So we shifting in the ADC value for one ADC, not all the ADCs. Okay, this is where this breaks, because we need like 8 ADCs here. Okay, let's start for the first ADC. First ADC, and then we can compare basically test din read sample to LED. Okay, this is where I try to get to today. So read the first sample and test it with whatever. We can, I don't know if we can display it today. I wanted to finish in half an hour. Okay. So let's use bits in. Oh yeah, we also need to reset bits in here. So this is funny because this happens at the same time. So we can even set bits in. What is the bit width? 13 D0. We can set it before that. It doesn't matter because this is happening at the same time, and it's safe that bits in. Oh, nice! It's a it's a late Christmas gift. Or do you plan to do barbecue on New Year's Eve? Bits in, and then we basically do that. What do we do? Yeah, we put in bits in. What is it? 12. ADC data. Ah, okay. Okay, this is basically shifting in the bits. Whoever like tries to understand, we are we shift. Okay, whenever it's smaller than this here, oh yeah, the timing here, 27, its settings, wait, why is, oh yeah, sample clock is 0, the sample for is not ready yet. We read in current bit, we read only in at rising edge here. So, oh yeah, and only like not on this edge here, but on this edge here. So we have to check, and then if on the rising edge of this here, current bit 0, because rising edge, because we use it inverted, like the first bit of our counter. This is, I should rename this. Current bit is like, it's current edge or something. Yeah. Can I replace it? Why is it, what is flickering here? The cheapo lights that I bought are flickering. Oh, now I'm blinded. Oh, it's 20 watts LEDs. current bit replaced by current. Bam. Close. Here we go. Okay. Let's see. What's oh yeah, that's one too many. Seems to work. Okay, now we need the LEDs. I have. Is it overheating? This would be stupid. Which one is flickering? Something's flickering here. Oh, now I'm really blinded. I shouldn't look in the... Ah, okay. We don't have anything connected in. Yeah, I don't know. Oh. Or is it just my eyes flickering? Yeah, LEDs. Let's check those. We need to get LEDs here. LEDs and switch the project again. Yeah, yeah, he is. Johnny, you evil monster. Okay. Yeah, I stay true to my camel case here. Okay, so we have 6 LEDs. I can basically... I'm just trying to make the world a better place. Yeah, stretch gold pink doesn't happen today. I'm sorry. These are not RGB LEDs. Don't try to switch. Okay. Now output. We have some output. 5, 0. Is it LED or LEDs? LED, okay. So always, let's make it always at pause edge, pause edge, sample clock, begin, and now we make like a small thing here. If sample is greater than, we have how many LEDs? 6 LEDs. I don't know, divided by 50. Okay, 250. Let's 200, 150, 150. If sample, let's 6 bits, something like that. Basically make it zeros here. Okay, let's make it more sensitive here. Else so higher than 230, let's say 200, I don't know, 70, some trash here. 30, 90, 90, 40, whatever. Ah! Non-register, oh yeah. Here we go. Now we should be able to connect an ADC and read analog values. Okay, my dudes. Okay, this is reading in some trash. Oh yeah, it's inverted. Oh wait, it's inverted. It's inverted. Yeah, it's inverted. It's inverted. I inverted. Ah. It's inverted. It's most probably inverted. Ah. It's probably still like random programming. Now the fun thing will be we will try to it's probably just random. Can I change it now? Okay. Let's make it work properly, okay? Let's make it. Oh wait, yeah, we need to. This is hot plugging. Might not be the right way to do it. I hope it doesn't completely break. And wave gen. Let me. I don't see anything there. Else sample. Okay. Let's see if we can get thankfully, my debugging tool, my debugging stuff here is fancy. So we can actually connect our probes to the first channel. Let me show you. Here, there is the chip select and first bit. We can even use 3 probes for that, but let me use chip select. This is more. Okay. This is quite. Why is this chip select? Oh wait, it's the wrong one. Okay, this should be chip select then. Yeah, these are okay. Okay. So, my friends, what you're seeing here, where's the trigger? Source is 2. Why is... Wait, what? Oh, this is clock, sorry. This is chip select. Oh shit, I touched something else. Okay, here we go. Okay. The ADC, do you see that? So the ADC likes the input, the clock and chip select input. We can see certainly bits, like low and high bits. Now, we don't see anything on the LEDs yet. But we see like a high impedance. I think this is like the high impedance or whatever for... No, it's not a botch. There is no botch. There is no botch. Okay, so we see a read in. I have a wave gen of 0.5 hertz. That's why you see like the bits growing and whatever there. So you see here, it's getting high bit, low, high, low, high. That's like a sine wave, okay? So we should be able to read the bits in. Now, why don't I see that? Why don't I see that on the LEDs? Okay, let's try something else. Let's try something else. Let me move that over there. It doesn't help us anymore. Instead of this bar, we do basically LED. Oh wait, this is no good. We should do something like that here. Okay. Yeah. However, LED. Let me move sample, and just use the higher significant ones. Okay. We just clamp it and let's see if we can move that. We can see movement on the LEDs. No, we don't see movement on the LEDs. Pause edge, sample clock. Oh yeah, I didn't upload. You're right. Let's see. Moment of truth. Moment of truth. Nope. Nothing there. 15 minutes left, okay. Yeah, WaveGAN is working. I see everything. We see the wave input here. This is the output of the first pin. Do you see that? This is the output. So the WaveGAN is 100% working. We should be able to read these bits here. So either I read at the bad moment, or I don't know what's happening right now, or we just have a bug in the code or ADC code here. So bits in. Try using ADCTS as the LED clock. Oh. Chip select. No, I can't. No, because I have a clock here. Oh, do you think it's never assigned? Hey, Ash. Oh, I didn't notice you. You haven't been here before. Okay, wait. We have a sample clock, so the clock should be. Oh. Wait a second. We have some code over here. Maybe that overruled everything. Ah. That was some old code. Okay, let's see. Yeah. Yeah, I still don't see it. I still don't see and don't feel it. Okay, let me try. Yeah. Okay, but now it should. Did we upload it? Yeah, we uploaded it. It doesn't. Okay. Let's try to assign something else than sample. Or let's do it like that. To see if we even assign anything. That's like 8 bits D0 and then wait, what? Oh. That's a wire. Okay. Wait a minute. Now here we go. That should be. Wait, wire. Where do I store it? No, that's not a. That should be wire because I don't have a stage here. Sample. Let me just, for testing reasons, just use the counter here. Just use the counter. Yeah, something like that. I don't care. Is this a coincidence? Lead is rag. It's not defined as a clock or whatever. Do I have to define it here? Okay, you know what? Let's do the following. Don't do that. Let assign let okay. And then 772, yes, like that, and we don't need all that trash here. Let's wait, begin, we don't need that. Okay, let's do that. And you use that. We can leave it there, I don't care. It doesn't do anything. And then we can see if it even flickers. Yeah, it's not doing anything. It's not doing anything. Why though? Do I have any warnings here? No what? Okay, clear. What? Okay, index 18. Oh, that's the problem. This is the start, and this is the count of bits. We have 13 bits. So we start at 4. This is the problem. I should have read all the warnings. Size 11 truncated. Okay, this is +1. Also das. Unused. Ah, shoot. Okay, now it should be warning free. Yeah, we clear that. This indexing style, I try to wrap my head around it, but unfortunately I made a mistake. Shifting bits is here. Yeah, sorry. This should be alright. Yeah. Yes! Yes! Do you see that? Do you see that? We can see. Okay, we are good. We are good. Looks okay. Looks okay. And we don't even need the clock. We don't need the clock. We can use it, but we should use it. We should use the clock. Okay, okay. Now let's get back to Ha! Ha! You are new to the what? How did you not wait? You are an expert on that. You don't know this addressing? This, my friend, is, I tell you what it is. This is something I learned during the ASIC designs. This is the start address, and this is the count of bits. You can use... You wrote a voodoo card or something. You can use a dynamical address here. So you can use like another like bits in or whatever here. Yeah, not cocky, because this is very important. You can use a dynamic start address here, but you wouldn't be able to use the other notation, because then you potentially have like a start and that wouldn't like, or a fixed thing like start +8 is not accepted here, because that might like change the size or whatever. What? The replication is cool. It's really cool. It's one of the first things that you try on learning sites. Yeah, this is quite convenient, because you can use an address here. This is like addressable memory. But apparently I did a mistake there. So don't take me as an expert here. And now we should change it to... Yeah, let's fix that, because I want to wrap up the stream. Wrap up the stream. Oh, wait. That's true. That's true. You can basically shuffle around the bits then randomly. Not randomly, but you can shuffle them around. Rec. Rec. Not assign. And now let's try if our clock works. And if that works, we can use the bar. And then we are done. Yes, oh, that's strange. You can even use negative indices and stuff like that. Okay, apparently that doesn't work. Oh, wait, I have wrong code here, sample. You know why I'm stupid? I'm trying to do all the bits at once. I should be able to like do one ADC and do like 8 instances of this. So this will be the next next time code. Yes. It has embedded flash here. It's cool, huh? Okay, this is working now. Okay, and now use the bar graph. Bar graph engaged. Everything is coming together, people. ADC mastered today. Boards fixed. 180 degrees rotated board fixed. Yeah, you missed that one, huh? Ash, you missed the one very later. Oh, that's somehow... That is somehow not what I expected. Yeah. Somehow the bar... there might be... No, it doesn't work. It should be like... No, it doesn't. Sample... Let me check if I have something wrong here. Huh? Yeah, it flickers, but it should be like a half a hertz bar moving up and down, and that's not doing that. So it's staged. It's staged. It has like only one edge and it's staged. So it shouldn't matter if I like also just wire it. Oh, wait. This isn't saved. This isn't stored. Let me compile. I don't know what I changed. No, that didn't change anything. It's the same bytecode, otherwise it would change like the checksum. Something. Okay, you know what? Let's use the other addressing style. Bye-bye. Tech. Happy New Year. Okay, so let's just use the last 12. Wait a second. Oh, wait a second. This is wrong. I shift the wrong way. Highest significant bit first. Here. Yes. Stupido. Stupido. Okay, here we go. What is this? Yeah, whatever. Okay, bar graph, incoming bar graph. Come on. What is that? Okay, I need to start at the lower sample. I need to start at a different sample here. Blink dirty. Yeah. Psst. Oh, now it's overdriven. Okay. It works. Let two bits. Almost. We should have a sine wave. Sine wave incoming. It was a little bit overdriven. Yes! The max what? Frequency, 3 megahertz. We can try a higher rate here. We can try a higher rate. Should we try a higher sampling rate? This is 100 kilohertz. Oh wait, that's the clock. Wait. 60 fold, 60. We can try. We can try to sample. This is not the clock. This is only the bit clock is 100 kilohertz. We can basically use 20. Yes, we can basically use this clock to sample at the rate, unheard of rate. This will be sampling at the unheard of rate. Hopefully. It still should look the same. I don't know what sampling rate. Checksum? No, that's all right. We don't need the counter. Look at this. Look at the scope. Yeah. Look at the clock now. Okay, so okay, 840 kilohertz. Okay, we have now a sampling frequency of 844 kilohertz. Now we can double that, or even more if we use like PLL. Okay, peoples, we have, this is 800 kilohertz. The only thing that we need now, here is your results. Here is the result. We are sampling really fast here. What we can do now is PLL clock to basically get 3 mega samples if you want. What? Yeah, forget it. All good, all fine. All fine. I can rework that to have like positive the big LEDs. We can separate, like remove the clock from here. Can it the live stream? Okay. Peeps, I'm looking forward to the next stream. Either I do it myself off stream, but you will see some serious business next week. So read sample to LED. That is our goal. We can continue with that next time. I might code a little bit if I'm tempted and display it on the LCD. Yeah. So everyone, thank you for joining the stream. It was a blast. I enjoyed it a lot. I wish you a happy new year and I see you next time. Yeah, guten Rutsch. Cue the music. Cue the music. Where's the music? Pum 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 pum. I can find it. Whatever. Bye bye everyone. Thank you for joining. I see you next time. Happy New Year. And great celebration. Where is the button? I want to kill the stream finally. Here we go. Mwah.